Today we're going to look at another way to solve quadratic equations. Last time we solved them by graphing, and that works really well if you have graph paper and can graph it, or if the answers are whole numbers. Remember that the solution to a quadratic equation is going to be where the parabola crosses the x-axis. We're looking for the zeros, we call it. That means when y equals 0. That's the solution. We solved by graphing, and now we're going to learn how to do that by solving by factoring, which takes us back to the last unit that we did. So I'm going to quickly review what we did in our last unit. Remember when factoring, the first thing you do is you always look for a greatest common factor. If there is a greatest common factor for all the terms, you're going to factor it out. And then from what is left, if there are 4 terms left, remember that we factored by grouping. We'll have an example of that here in just a minute. If there were 3 terms left, after taking out the greatest common factor, and the A term, or the first term, was equal to 1, we use something called reverse FOIL. If there were 3 terms left and the first term was greater than 1, sorry, that should be greater than 1, we did something called slide and divide. And then we had 4 terms, and we factored by grouping. And if there are 2 terms left, we are going to look for the difference of 2 perfect squares. Okay, so this is a review of everything we did in the last unit, and we're going to be using that today to solve quadratic equations. So that's just kind of a rundown of what we did. So now let's look at some examples of this. In our first example here, you will see that we have 3 terms, and the first term is 1. So we're going to factor it using reverse FOIL. A reminder as to what reverse FOIL is. You look at the C term, which is 10, and then you're going to look at factor pairs that multiply to get 10, and then you're going to look for which pair is going to get the sum or add together to get the B term. If I add 2 plus 5, that makes 7. So now when factoring it, I know I'm going to use 2 and 5, a positive 2, so that's x plus 2, and a positive 5, so that's x plus 5. Now that's where we stopped when we were doing our factoring unit. Now we want to use this and go one step farther and use it to solve quadratic equations. Remember that the solution is always where y is equal to 0. We call it finding the zeros, where it crosses the x-axis. So we're going to set the entire thing equal to 0. Now, we know that one of these binomials has to be 0, because in order for the answer to be 0, one of your factors has to be 0. So what we're going to do is we're going to set both separately equal to 0 and solve with a one-step equation. So either x plus 2 is equal to 0, x plus 5 is equal to 0 to solve for x. So you have to move 2 to the other side, so x would be negative 2. Here we would move negative 5 to the other side, and x would be equal to negative 5. So here's our zeros. We know on this parabola, if we were to graph it, that 2, 3, 4, 5, it would cross at negative 2 and negative 5. So those are our solutions. That's doing it with reverse FOIL. Okay, so if you're following the PowerPoint, then I'm having a hard time with technology. Okay, so there it shows it. Okay, with our next example, again, we have a trinomial. We have 3 terms. Our first is always to check for a greatest common factor. I do not see a greatest common factor, but I do recognize something that we have here. We actually have the perfect square trinomial. Do you remember when the first term was a perfect square? I can take the square root of that. That would be 3x. And I can take the square root of 25. That would be 5. And then if you multiply them together and double it, so 3x times 5 is 15x. and 15x doubled would be 30x. We have a perfect square trinomial, so I know to factor it, it's just 3x plus 5 squared, or I can write 3x plus 5, 3x plus 5. So this time there's only going to be one solution. Here's an example when there's one solution. Because 3x plus 5, I don't need to do it twice, but I do need to set it equal to 0. To solve for x, first we move the 5 to the other side. That gives us 3x equals negative 5. Then divide both sides by 3. And we have one solution. So it crosses, that means this parabola goes up and it crosses at negative 1 2/3. So it's going to touch the line about right there. So that's an example of how you can have one solution when you have a perfect square trinomial. Okay, if the equation is not written in standard form, first you have to rewrite it in standard form. In standard form, we have to have everything on the one side of the equation and the y over on the other side, which we're going to replace with 0 because we want y to equal 0. So I'm going to move 5 to the other side. When I move it to the other side, I have to subtract 5 from both sides, so it becomes a negative 5. We want y to be 0, so I set it equal to 0. Now we're ready to factor. I have 3 terms. The leading coefficient is 1, so I use reverse FOIL. I want two numbers that multiply to get negative 5 and add together to get negative 4. Here's my pair, so that would be x plus 1, x minus 5. We're going to set both of those equal to 0. Oops, that's a minus sign. X minus 5 is equal to 0. And when we subtract 1 from both sides, we find that x is negative 1. Or we add 5 to both sides, and we find that x is equal to 5. So this time, it's going to cross the y-axis at 1 and negative 5 if you were to graph that parabola. Now it's interesting, and it'd probably be good for you to note that once you get it set up right here, the solution is just going to be the opposite of each one, because once you set it equal to 0 and solve, instead of a positive 5, it's going to be a negative 5 because you had to move it to the other side. So once you've got it factored to this point, you're just going to take the opposite of what that number is, and that's what the solution is. Because that's what happens when you solve it. All right, so again, this one is not written in standard form. So I'm going to keep my leading coefficient positive, and I'm going to move the 13x to the left side, and I'm going to move the 7 to the left side and set it equal to 0 because I want y to be 0. Here, the leading coefficient is greater than 1. It's a 2. So this is where we have to multiply the first term times the last term. That equals a negative 14. And we want to find factor pairs that make a negative 14 but add to get the center term of negative 13. So if I have a negative 14 and a positive 1 that multiplies to get a negative 14 and adds to get a negative 13, now we're going to slide and divide. If you remember that, it means we keep the first term, we slide it down. We keep the c term, slide it down, and we divide this middle one into two parts. We have 1x and negative 14x, and you can decide which one you want to group. I think I'm going to put the 1x on this side, and the negative 14x on this side. Now we solve by grouping. So we look at the first pair, we pull out the greatest common factor. What is left? So when we factor over here, we should get a 2x plus 1 left over. What do we need to factor out? Would be a negative 7, because this divided by negative 7 and this divided by negative 7 would give you your 2x plus 1. Now remember, we look for the magic. One of your binomials is x minus 7, and the other one is the 2x plus 1. Now we're going to set both of them equal to 0. So we know that this one is going to be 7. One of our solutions is 7. And then this one's actually a two-step equation. So we move the 1 to the other side. That would be a negative 1. Then we divide by 2, and so x is actually equal to negative 1/2. So it's going to cross the y-axis at 7 and negative 1/2. Okay, here's our next example. Again, it's not written in standard form, so we want to do that first. So I'm going to keep the a squared on this side, the negative 8 on this side, but I'm going to move the negative 15 to the left side. It's going to become a positive 15, and we're going to set that equal to 0. 3 terms. The leading coefficient is 1, so I use reverse FOIL. So I need factor pairs for 15. We have 1 and 15, 3 and 5, but I need the sum of negative 8. To get a sum of negative 8, I'm going to have 2 negatives here, because multiply together, that makes a positive 15, and when you add them, it makes a negative 8. So when we factor it, it is a minus 3 and a minus 5. When you set both of those equal to 0, you know you're going to get the opposites. So the answer is going to be 3 and 5. But I can show you that if you add 3 to both sides, see how it just changes the sign? So a is equal to 3. And then if you move the 5 to the other side, it's going to be the opposite, and a is going to be equal to 5. So it would cross the y-axis at 3 and 5. Doesn't matter what order you put them in. This is not an ordered pair where you have to put the x first and the y first. There are just 2 solutions. So 3 and 5, 5 and 3 means the same thing. Okay, here again, it's not written in standard form, so we're going to move the 5 to the other side. So we have 3p squared minus 14p minus 5. We have 3 terms, and the leading coefficient is greater than 1. So again, we have to multiply the first term and the last term together. That makes a negative 15. I need factor pairs that multiply to get a negative 15, but add together to get a negative 14. So that would be this pair right here. So this is my slide and divide again. So I keep the first term, keep the last term, and I'm going to divide the middle term into 2 parts. I'm going to do the 1p on this side and the negative 15p on this side. Now we factor by grouping. Here's the first group. What can I factor out? A p. That leaves 3p plus 1. So we know when we factor this side, we're going to have 3p plus 1. And what do we factor out? A negative 5. Because this divided by negative 5 would be a positive 3, and that would be a positive 1. Look for the magic. Our first binomial is p minus 5 equals, set that equal to 0. So we know one of the solutions is going to be a positive 5. And we have to set 3p plus 1 equal to 0. Now you know you're going to have a fraction because we have a two-step equation here. Move the 1 to the other side. You would have 3p equals negative 1, and then divide by 3. So the zeros are it's going to cross at a negative 1/3, and it's going to cross at a positive 5, if you were to draw that parabola. So the answers are 5 and negative 1/3. Okay, if you'd like to see some more practice, here's a 2 term. Remember, in this 2 terms, we want to check for the difference of 2 perfect squares. Can you take the square root of 4x squared? Yes, you can. It would be 2x. Can you take the square root of 64? Yes, you can. It's 8. So remember, to factor that, we do 2x minus 8 and 2x plus 8. Now we're going to set both of those equal to 0. So now we're going to have 2 fractions as our answers, because anytime you have a 2-step like this, it's probably going to be a fraction. We move the 8 to the other side. That would be 2x equals 8. Divide by 2. That one happens to be a whole number of 4. 2x equals negative 8. Divide by 2. No fractions here. X equals negative 4. So 4 or negative 4. That turned out nicely. You didn't have to have a fraction come up. Okay, again, we check for the difference of 2 perfect squares. It's not. You can't take the square root of 18. But there is something that I can do, and that's the first step. Always check for a greatest common factor. They have the greatest common factor of n. When I factor it out, that's n minus 18. So one of these, either the n or the n minus 18, has to be equal to 0. So we set the n equal to 0. So there's one of your solutions already. And then we say n minus 18 is equal to 0. And when we move that to the other side, we find that n could be equal to a positive 18. So it's 0 or 18. More practice. That's not written in standard form. So I'm going to keep my leading coefficient positive. So I'm going to move everything to the left side. I'll make that a negative 3x and a negative 40. Instead of equal to 0. 3 terms. The leading coefficient is 1, so I use reverse FOIL. So I have to think what factors are there for negative 40 that would make a negative 3. Well, we have 1 and 40, 2 and 20, we have 4 and 10, and we have 5 and 8. Ooh, this has possibilities. What if we used a negative 8 and a positive 5? That multiplies to get a negative 40 and adds to get a negative 3. So when we factor it, it's going to be x minus 5 and x plus 8. One of those, we're going to set both of them equal to 0 because that's what we're looking for is when y equals 0. So of course, when we move it to the other side, it changes the sign. So x is, it crosses at 5, and it's also going to cross at negative 8. Just have to change the sign on both of them. So that one, if you were to graph the parabola across the x-axis at 8, negative 8. We will be doing some more practice. Good luck with that.